Hello everyone, welcome back to the map of mathematics. In this video we are going to solve this nice exponential equation problem, and here we have a to the power of n plus 2 to the power of n equals to 130, and we will solve this problem for the values of n. So the very first thing we are going to do is, here first we rewrite this equation as, here we have 8 and we can write this 8 as 2 cubed, because you know that 2 cube equals to 8, and we write it as 2 cubed and its whole power n plus 2 to the power of n equals to 130. And now we will use here the nice exponential law, and you know about this law. If we have a to the power of m and its whole power n equals to a to the power of m times of n, or we can write it as a to the power of n and its whole power m. So it means that if you can interchange these two exponents, then it cannot be affect its final answer. So here we need to interchange these two exponents, and we will write it as 2 to the power of n and its whole cubed plus 2 to the power of n. We move this 130 in the left hand side equals to 0. And now in the next step we will convert this exponential equation into the quadratic form, so that here we can take y equals to 2 to the power of n. So when you take y equals to 2 to the power of n, then the above cubic equation will become in the form of y cubed plus y minus 130 equals to 0. So this will become in cubic form, and now we can make the factors of this cubic equation. So here first we write y cubed plus y minus 130, and we write it as 125 minus 25, and this whole equals to 0. After this step we will arrange y cubed with 125, and you write y cubed minus 125 equals to 5 cubed, and we make the pair of y with 25, and this whole equation equals to 0. So now in the next step we will use here the cubic formula, and you know that if we have a cubed minus b cubed equals to a minus b times of a square plus ab plus b square, so that we will apply here the cubic formula on the first term, and you get its output in the form of y minus 5 times of y square plus 5y plus 25, and plus here we have y minus 25, and this whole equation equals to 0. So that sorry, here we have one mistake, which is here you can write 125 minus 5, it is equals to minus 130. So that here you have y minus 5, and here you have y minus 5. So now we will take y minus 5 common on each term, and you get y minus 5 times of y square plus 5y plus 25 and plus 1 equals to 0. So that here we have two cases. The first case is we take y minus 5 equal to 0, and the other case is we take y square plus 5y plus 26 equals to 0. So here you get the value of y is 5, and similarly here you obtain, or here you first check, is this quadratic equation has real roots or not, because in this problem we need to find the real roots. So that first I will check this quadratic equation has real roots or not by using the discriminant formula. So here we have a equals to 1, b equals to 5, c equals to 26, and the discriminant formula is delta equals to b square minus 4 times of ac, and we put the values of a, b and c here, and you check the behavior of this function. So that the value of b is 5 square minus 4 times of a is 1 and c is 26. So here you have 25 minus 4 times of 26 equals to 104, and when we subtract these two, then you get minus 79. So here you see that when the value of this discriminant is less than 0, then it means that it has no real root. So if it has no real roots, then we will reject it this case, and we can just proceed here this case only. So in this case we have y equals to 5, and in the start of the problem we will take here y equals to 2 to the power of n. So it will becomes 2 to the power of n equals to 5. And now in order to find the value of n, we will take the log on both of the sides. Then you get log 2 to the power of n equals to log 5. And here we apply the property of log, and we move this exponent in the front of this log, and you get n times of log 2 equals to log 5. So that we move this log 2 in the right hand side, and it will becomes n equals to log 5 over log 2. And in the next step we will use the calculator in order to find the value of log 5 and log 2. So the value of log 5 is 0.6989, and the value of log 2 is 0.3010, and when we divide these two values, then you get 2.321. So this is our final value of this problem. And thank you so much for watching this video. Please subscribe to my channel for more exciting videos.